Now, so if it's not, if the difference between the seasons is not the distance, then what is the reason that the summer is hot? Well, let's do this. Okay. There's two basic reasons. And one of them is what a bunch of you actually already posted up in the chat a little bit further. Check this out. If you are living right here, this right here, let me draw, this has got too much stuff on it. Let me draw another version of that that's simpler. Let's say we got the sun right here, and the earth is right here. So that this is the equator, this is the North Pole, and this is the South Pole. So, real quick, if this is the shadow behind the Earth, would this be winter or summer for this person living in Florida? Would that be winter or summer right there for this person living in Florida? Winter or summer? I think we have a little bit of a delay. Here we go. Is that winter or summer for the northern hemisphere? It is winter. That is correct. It is winter. Because this person is on the part of the planet that's tilted away from the sun, they're going to have winter, okay? And as the Earth rotates, as they rotate, they're going to, that's their day, right? They spin around the Earth like that. And you can see right here in the winter, they spend more of their rotation in the darkness. They're only in the day for this little part of the rotation, right? So that means they're not going to get daylight for very long. On the other hand, somebody living down here in Australia on that same day is going to be having summer, right? And so when they spin around the planet, they're going to spin around like this. And you can see here, they spend more of their rotation in the daytime side of the planet. So the first reason that the summer is hot and the winter is cold is the length of daylight. The length of daylight, okay? So in the summer, you're going to have a lot of daylight, and in the winter, you're going to have only a little bit of daylight. So basically, in the summer, because you are tilted into the sunlight, the sun has a longer period of time to heat the ground up, and therefore make you feel hotter, okay? So the length of the daylight is the first reason that the tilt matters, okay? There's another reason, though, that is way, way more important, okay? That last reason that the summer is hot and the winter is cold is the angle of the sunlight. The angle of the sunlight. Now, check this out. Let's say we're going to draw two pictures. Here's the ground during the summer. And here's the ground during the winter. Now, in the summer, if we look back at this page, this person right here, don't overthink this. Where would this person have to look in the sky to see the sun? Which way would they point their head to see the sun if they're standing right here in the summertime part of the planet? Which direction would they look? Straight up, right? This person would look straight up to see the sun. So that means in the summer, if you're standing right here, the sun's going to be pretty close to being straight over your head. I'll put sun right there. The sun is pretty close to being straight over your head. Okay? Now, that's somebody in the summer. Over here, this person, so somebody's asking, is this the reason specifically for summer, or this is for summer versus winter, okay? This is for summer versus winter, because again, this person is standing in the summer part of the planet, and as we said, they would look straight up. This person is in the winter part of the planet. If they look straight up, they're looking over here. That's not looking at the sun. Where would this person in the winter part of the planet have to look to see the sun? Where would they have to look? They're not going to look straight up. Where are they going to look? Yeah, off to their side. Off to the, in this picture, off to the left, right? They'd have to look kind of over this way, right? So in the winter, that means, let me put the person standing kind of way over here. The sun is not going to be as high in the sky. It's going to be off to your side even at noon. It never goes, it's not going to get very high in the sky, right? So this is going to change the angle of the sunlight, okay? In the summer, that sunlight is coming basically straight down at you, whereas in the winter, all the beams of sunlight have to come in from an angle like that, okay? Now, why is this important? For two reasons, okay? The reason that the angle is the most important thing that makes the summer hot and the winter cold is because of two reasons. Check this out. Look at this one beam of light. This one beam of light is the exact same beam of light in the summer and in the winter. It's just coming in at a different angle. But that beam of light carries only a certain amount of heat in it. It's the same amount of heat here and here, but there's only a certain amount of heat to it, okay? And let's see what happens when that light hits the ground, okay? In the summer, that beam of light is coming almost perfectly straight down. So all of that heat goes into this ground right here, okay? All of that heat hits that amount of ground. Whereas the same beam of light, because it's coming in like this, in the winter is going to do this. Here we go. Uh-oh, I'm going to have to extend my picture. So because it's coming at an angle, it doesn't all hit the ground at the same time. And what happened to the amount of ground that that beam of light is trying to heat up? What happened to the amount of ground that the light is trying to heat up in the winter? Is it trying to heat up the same amount of ground? Less ground or more ground? It's bigger. Yeah, it's more ground. Now check it out. That beam only had a certain amount of heat in it. So if you spread it out and make it heat up more ground, like this, then that means you're spreading your heat thinner. Okay? And yeah, this is actually one of the reasons that plants have a harder time living in the winter. Because if the light is more spread out in the winter, then that means each individual leaf on a plant would get less of that light because it's being spread out, right? So basically, one of the main reasons that the angle is important is that in the summer, the light is very concentrated because it's coming straight down. And in the winter, it's very spread out, and that heat is spread thin. So that's one reason that the angle of the sunlight is important, okay? Now, on the other hand, check this out, that's not the only reason this angle is important. Here's my next question. Have you guys ever been to a lake before? You probably have been to a lake, right? And imagine you took a bunch of rocks to that lake, okay? You took a bunch of rocks to that lake. And actually, let me just draw a quick picture of this. Imagine you went to the lake. So here's like the edge of the lake. And you stood on the edge of that lake and you threw your rocks straight down. Here's your hand. Ignore this guy's monster arm. Sorry. He's releasing some rocks straight down. Okay? Here's a rock. He's throwing it straight down. What's probably going to happen to that rock when it hits the water? If you go out and throw a rock straight down at the water, what's probably going to happen to that rock? Don't overthink this. Yeah. It's going to sink. It's going to go in the water. You could say it gets absorbed by the lake. That rock's going to go just into the water and keep going down, okay? It gets absorbed by the lake, okay? Now, on the other hand, let's say you went up to the same exact lake, and this time, you threw your rocks so that they were going at a really shallow angle, like this. Does anybody know what will happen when the rock hits the water like that? If you throw it at a very shallow angle instead of straight down, what might happen when the rock hits the water? Well, it could make a splash either way. But have you ever gone to a lake and kind of just like flung the rocks kind of like at this real shallow angle? It'll skip, right? If you threw it just right at a shallow enough angle, you might end up getting it to bounce off the water or skip, right? Now, here's the thing. What is light? It's actually a really hard question. But one way to think of light, and we'll talk more about this later, is actually as a stream of particles. So light, any beam of light, if you could somehow get in microscopic enough, is actually a stream of little light particles. Does anybody know what a particle of light is called? People don't always know this one. It starts with a pH. Does anybody know what a little particle of light is called? It starts with a pH. No takers. That's okay. I was just trying to see if anybody happened to know it. It's called photons. Photons. So, there's somebody got it. There you go. So light, one way to think of it is just as a stream of little particles called photons. Okay? So that means that every beam of light, like a flashlight beam or a sunbeam, is actually kind of like a bunch of little pellets hitting you. A bunch of tiny little pellets shooting out of that whatever is shooting the light. So the sun is just shooting tons and tons and tons, millions of little pellets in every beam of light, right? Little light pellets. Right now, the lights above you are probably hitting you with billions of little light pellets a second. Just pop, 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 pop. Can any of you guys feel these little light pellets on you? Can you feel the little light pellets? Anybody feel them? Feel like you're getting shot with a little toy machine gun or something? No, you can't, right? You can't feel that because they're way too small, right? They're way too small, so it's not going to hurt you or anything. But let's see where I'm going with this. Check it out. In the summer, the sun is shooting those little pellets straight down. So when they get to the ground, Just like this rock, when you throw the rock straight down, it goes into the lake. So when these little pellets of light come straight down, where are they going to go when they hit the ground? Where are these little light pellets going to go when they hit the ground if they're going straight down? I'm trying to use this as a metaphor. Where are these little light pellets going to end up? Inside the ground. Yes, inside the ground. Just like the rock that you threw straight down into the lake, it went into the lake. When the sun shoots these photons straight down, they're going to end up going into the ground. And what that does is it heats the ground up, right? The only way for us to actually get heat from the sun is for it to get absorbed by the ground, and that's what makes us feel hot, okay? Whereas, let's see if we can see where I'm going with this. In the winter, the sun is shooting those little pellets of light at a shallow angle. What might happen to some of these pellets of light when they hit the ground? What might happen in the winter to some of these little pellets of light? What might they do when they hit the ground like that? What might happen? Somebody's giving it a try. I'm going to see if they get it. What might happen here? Again, use the lake metaphor. Yeah, they skip. Light skips. So some of that light, some of it will go into the ground, but some of it will skip and not get absorbed. Yeah, some of it will skip and not get absorbed. So this isn't technically refraction. This would be just called reflection, okay? Basically the same as like what happens in a mirror, okay? So just like this rock skips when you throw it at a shallow angle, light can skip when you throw it at a shallow angle. So not only is the winter cold because this light is spread out, it's also extra cold because it's easier for the light to bounce off the ground and take its heat back off to space in the winter because of skipping like stones. It's much less likely to bounce off the ground in the summer. So we keep all of that heat, okay? So if I asked what is the most important reason that the summer is hot and the winter is cold, it's the angle of the sunlight that's the main thing.